Good evening, sir.
Sir, please unmute.
Let us start. What is EMF? Electromotive force. Right. To understand this, let us draw a circuit diagram. Now look here. All of you are familiar with the circuit. Yes, sir. इसको बोला जाएगा. इधर आओ. हाँ दोनों. तू भी आ जा. मेरे से दोनों आओ. बैठा क्यों तू? इधर खड़े. यहाँ खड़े हो. अभी तो यहाँ खड़ा हूँ. बाद में बाहर भेज दूँगा. ठीक है? पीछे हो. Don't block him. Side by side खड़े रहो दोनों. पीछे कर, पीछे कर. So this is a electric circuit. Now the girls' turn for this time. Please pay attention. Okay. So we have resistance. What is this? This is a cell now, right? Cell is source of electric current in the circuit. All of you are familiar about it. And this is the rheostat. This is the current regulating mechanism or current controlling mechanism. Like I explained in the last class, this is key. Now, what is this small resistance? This is called internal resistance.
Internal resistance.
And cell has something called as E, the EMF of the cell, right? Now let us understand what is E. So E is the EMF. So if I show you the cell structure, once again I hear you all talking, that's the last ultimatum, okay? मेरे को समझ आ गया तुम दोनों बैठ के गप्पे मारो. So how is a cell? Is the cell structure? What is there inside a cell? You have electrodes. You have electrodes, right? So let us say it is made up of copper and zinc. Let us say it could be any combination. So there are various combinations possible. Then it is filled with electrolyte. So what is electrolyte? Yes, it is some diluted acid. So electrolyte is diluted H2SO4. So when it is diluted, okay, then this hydrogen exists as ions. And this is minus, right? So these ions are mobile now. Like in if so, this is also now a conductor. That means current will pass through it if it is dilute H2SO4. So what happens is these positive ions, right? They react. So this positive ion H2 reacts with copper, and it actually takes two electrons. Then it becomes hydrogen gas, and it comes out. But when it has taken two electrons from copper electrode, then this electrode becomes positively charged because of this chemical reaction, right? And this will go on till there is an equilibrium state reached between the copper rod and electrolyte. Okay? So there will be buildup of positive charge on this rod till it reaches equilibrium. Likewise, this will get deposited on zinc and it will make something called as zinc sulfate. Every time it gets deposited over here, it will receive two excess electrons. And this also will reach a equilibrium state. What do I mean by equilibrium state? Now the plus or the positive charge is so much that it will now repel this H2 ions. It will not let this positive charge come near it. Okay, so no more reaction possible. So that balance state is called equilibrium state. This positive charge buildup is called as high potential. Okay, this is at a high potential. Right? And this is called as low potential. Now there is a potential difference. There is a potential difference, yes, right? So therefore, if any outside resistance or any outside load is connected, so there will be a flow of current. How this flow of current is taking place? One electron will come from here like this, and it will neutralize plus, right? The moment this happens, again, this lost electron will be supplied on both the terminals. So an electron here and a positive charge here, like electron yahan se kya hoga? It is like you can see it as electron going from here to here. But there is no electron movement inside the electrolyte. What is moving inside the electrolyte? These ions. Okay. So electron only moves in the external conductor. What moves here? The ions. So current in the electrolyte is because of the movement of ions. These are the charge carriers inside the electrolyte. Got it? Now, here there is a collision between the stationary charges in the conductor with the electron. So that is the obstruction. So that resistance is capital R. That is the external resistance. Okay. Whereas this electrolyte substance itself is matter. So there is some resistance of the electrolyte substance. So that is the internal resistance of the cell. That is depicted as small r. Got it? So what is internal resistance? It is the resistance of the substance of the electrolyte. Got it? So this is shown along with the cell. Is it clear?
Yes, sir. Yes.
Okay. So now what is EMF and what is terminal potential difference? This definition has to be very, very clear. Okay. So understand carefully. EMF is, what were you doing in the break? Can you sit with the urine? Sit with it. That's the punishment. You don't have any disease, na? Ki nahi pass. Hold it. Okay. Now, you don't have bladder leakage problem, right? So, now, what is EMF? EMF is, now let's understand what is EMF. देखो, EMF is work done. Everybody pay attention. Very important concept. EMF is work done in taking a charge, right? Unit positive charge through the full circuit. Now, what is the full circuit? See, outside the cell, it is external circuit. Then inside the cell, so current, it is the same current. When current I flows, it is throughout, right? So current I flows outside the cell as well as inside the cell. It is the same current. Got it? So this is external circuit. From where, let's say this is point A and this is point B. So from A to B outside the cell is external circuit, right? And from B to A is through the cell. Yes, internal. So EMF is the work done in taking a unit positive charge through full circuit. Through full circuit, internal as well as external. Okay, that is EMF, right? Which means, and how it is defined as is, when you buy a new cell, right? So when the cell is not in use, when the cell is not in use means when no current is drawn from the cell. That time, whatever is the potential difference between the terminals of the cell is called EMF. So EMF is nothing but potential difference only. Remember, V was work done per unit charge. That was the definition for potential difference in the last chapter. So that is same work done in, but how? Work done in taking the unit positive charge through full circuit. That is EMF, right? Now, what is terminal potential difference? See, what happens is there is a resistance inside also, right? So terminal potential difference is defined as work done in taking the charge through external circuit. So it is the work done in taking the charge only through point A to point B, not also from B to B. So starting from A to A is E, right? But work done only in the external circuit is called E. Got it? And there is a small potential drop. Let's call that as small v. Because there is a resistance inside also. So whatever is work done in taking a unit positive charge between B and A through the cell, that is called potential drop. Okay. So what is the potential drop? This is a small work done in taking a unit positive charge from A to B. So for you to remember, so work done in taking a unit positive charge through full circuit, right? That is from A to A. From A to A, right? So A से start किया, पूरा फिर से A पे ले गया. That is EMF, right? Here, work done. Like here, in this case, cell not in use. No current drawn from the cell. It is cell not in use. When cell is not in use, only then this is possible. Okay? So this is a theoretical concept. You will never get potential difference between the terminal of the cell equal to EMF. Because once the current is passing, some of the energy will drop here. Okay? So it is this which is of practical importance. You got it? So what is this? This is work done in taking a charge, unit positive charge, outside the cell, that is in external circuit only. That is from where to where? From A to B. From two terminals. Between two terminals. Okay. What about it? Work done in taking a charge from B to A through the cell. So work done. You both said quite better. Work done in taking a unit positive charge through the cell. By overcoming its internal resistance. That is from B to A. Only between these 2 points. Is it understood? So what is the total work done? Therefore, total work done W must be equal to work done in external circuit and work done in internal circuit. Correct? Yes. So dividing it by Q, we get W dash by Q. That's W by Q. Right? What is it? So therefore EMF is equal to right? EMF is equal to terminal potential difference plus potential drop. So what is V? This is denoted as potential drop inside the cell. Got it? Listen. So then by Ohm's law, what do we get by Ohm's law? V is equal to capital IR. This will be capital I into small r. Yes, sir. Right? So what is it? So therefore, this is equal to I R plus R, or I is equal to E by R. Right? Sometimes, okay. This is it. So these are the relations that you will remember. So by Ohm's law, this can be written as E plus small I.
Sir, in the exam, they ask us the difference between capital V and small v. Can also write capital V like when the circuit is.
So capital V is the potential difference between the terminals of the cell when the current is drawn from it, when cell is in use. Right? The cell is not in use, but here cell is in use. Cell in use. Okay. So when the cell is in use, that means current is drawn from it. What is the job of cell? To give current. Okay. तो जब करंट देता है ना सेल तो उसके टर्मिनल उसका जो पोटेंशियल डिफरेंस है वो कम हो जाता है क्यों क्योंकि कुछ उसके अंदर ड्रॉप हो जाता है गॉट इट सो दिस इज अ वेरी यूजफुल रिलेशन V plus IR this you understood by Ohm's law right अगर इसमें Ohm's law नहीं लगा सिर्फ इसको V रखते हैं तो you get one more relation E is equal to V plus IR ठीक है ये भी एक रिलेशन बाय ओम्स लॉ सो ओम्स लॉ क्या होता है प्रोडक्ट ऑफ करंट थ्रू द रेजिस्टेंस एंड रेजिस्टेंस IR वैसे फिर से ओम्स लॉ लगा दिया तो ये भी बाय ओम्स लॉ सो यू कैन गेट वेरियस फॉर्म्स ऑफ रिलेशन बिटवीन E V and I. That's it. So you just need to know this relation. एक ये अगर याद हो गया तुमको E is always equal to V plus IR और V is equal to E minus IR. ठीक है? ठीक है? So that's it. V is equal to E minus I. You can solve all the numericals with just this formula. This, and now we are going to do combination of resistances. ये बहुत conceptual है, सबको समझ आ गया?
Yes, sir. सर लिख रहा
हाँ, लिख लो. 3 लाइन में derivation है, derivation पूछ कर. Derive the relation between EMF, terminal potential difference, and internal resistance. What is internal resistance? It is the resistance of the material of electrolyte. So all this definition I have already explained when I was explaining potential, right? Unit charge में Q क्या कहाँ से आ गया? Suppose W was the work done in taking charge Q through the circuit. So in taking unit charge, it will be WI. That's how it is. Okay. So read through the book. If you have any question you want me to explain, I'll explain here. Then I'll move on to next topic. Because this electrode which I have shown as a rod, it could be in the form of plate also. Right? Anything is possible. This shape could be plate. Okay, the one which is dipped in the electrolyte. और बाहर में contact निकाल दिया. ठीक है? So depending upon the area, its internal resistance could be more or less. Correct? More area means less resistance. Oh, यहाँ पे हो. So we'll see that factors affecting EMF and factors affecting internal resistance. Which one is that? This one? Yes. Anybody has any question here? There is a weak capacity. So online students, any question?
No, sir.
So you read the blue boxes, and try to correlate with what I have just done on the board. Just read the blue boxes. Okay, are you done with reading the blue boxes? And you can also read the differences between EMF and terminal potential difference. Last page of your yes. Kita, right? Why are you laughing? Any doubts? Okay, so let's proceed. Which topic?
That's how we told us starting on easy chapter. Not only
I don't think you would expect so pay attention. I'll be talking this maybe next week. Okay, any questions, anybody? So let's
relation of
that is what it is. Suppose I want 1,000 rupees. So can I spend more than 1,000? No, right? So that 1,000 rupees will be divided into some. I'll keep some money for myself, my own expense. That is small b. Let's say I keep 200 rupees for myself, and 800 I can spend on my family members. So that is the external expense. So whenever there is an energy source, okay, all the energy it needs some energy for its own upkeep. That's what it is. It's law of conservation of energy. Okay. So E is the total energy available with the cell. Some of it will be wasted by the cell, by its internal waste. Like I will breathe, right? So whatever energy I have, it's not all available for outside work. I will also need energy for myself. That is small v. So this energy is not available to do outside work. So it is V which is of practical significance. This is the surplus energy available for me to drive light, fan, etc. Understood? Yes, sir. That's it. So whatever is available, only some part is available for external work, and some will be used by the source itself. That's it. Okay. Any other question? Okay. So what are the factors on which this EMF will depend on? So keep the cell structure in mind, okay? Yes, so no, so read through the points, right? Factors affecting the EMF of a cell. It is given after equation 8.18 your book.
8.1.
जो E is equal to W by Q है ना उस equation के बाद. So it depends on the materials of the electrode, right? The electrolyte used in the cell. However, it is independent of the shape of the electrode, the distance between the electrode and amount of electrolyte. So EMF only depends on material of the electrode and the electrolyte used in the cell. So I told you 3 different types of cells. Yeah. Right? One had the EMF as 1.08. The other one had 1.5. So it depends on the combination of electrolyte and electrodes. Okay? So EMF depend on only these 2 things. Then let us see what are the factors on which. Should I write it on the board?
Yes, sir.
Okay. So EMF depends on the material of the electrode. Who is that? Material of the electrode. Okay. Second is the electrolyte used.
Temperature.
The electrolyte used. Okay, it depends on two things. The material of the electrode and the electrolyte used. Okay, what about the internal resistance? EMF E. Okay, EMF is E. Then we have the internal resistance. R. What will it depend on? Yes. So it will depend on shape and size, right? So there are four factors. Surface area of the electrode. One is surface area of the electrode. How will it depend? If I had shown you, right, the electrode could be in a plate form. So it will have large surface area. When the surface area is more, the resistance should be less, right? So that is R is inversely proportional to surface area. Second, if the distance between the electrode is more, then the resistance should be more, right? Same thing. So it will depend on distance between electrodes. Okay. So let's say it is dependent directly on distance. If the distance is more, then the resistance will be, internal resistance will be more. Then the nature and concentration of electrolyte. So how it will be? So nature and concentration of electrolyte. When the ions in the electrolyte be free to move, when it is concentrated or when it is diluted?
Diluted.
So more concentrated the electrolyte is, less ions. Therefore, resistance will be more concentration, more resistance. Okay. So it's directly proportional to concentration. Got it? Of electrolyte. With temperature, its resistance reduces, unlike conductor. Conductor में क्या होता है? Collision ज़्यादा बढ़ जाता है. But यहाँ पे क्या होता है? Electrolyte के केस में उसका resistance कम हो जाता है. So this you have to keep in mind. The distance, length and A is same as resistance, but temperature same नहीं. Okay? So internal resistance is inversely proportional to temperature. Rise in temperature leads to reduction of internal resistance. Distance between electrodes. So R, the internal resistance is directly proportional to the distance. Distance ज़्यादा है तो resistance भी ज़्यादा है. Okay. So you read these 4 points in the book and see if it is clear. Factors affecting the internal resistance of the cell. Okay. So, if there are any doubts, let me know, or else we'll move to combination of resistors. Any doubts in factors which affect EMF and internal resistance? Third one. Nature and concentration of electrolyte. देखो, electrolyte कैसा होना चाहिए? Dilute होना चाहिए. जब lose होगा ना, तो ion easily move करेंगे. अगर कॉन्सेंट्रेटेड है तो आयन पहुंच ही नहीं पाएगा इलेक्ट्रोड पर। Got it? मतलब कॉन्सेंट्रेटेड है मतलब सॉलिड ही होगा ऑलमोस्ट। तो सॉलिड ही होना चाहिए, वो ऑलमोस्ट लिक्विड डाइल्यूटेड होना चाहिए। समझ आया?
फ्री टू मूव
फ्री टू मूव होगा जब डाइल्यूट होगा।
नहीं है तो फिर रेजिस्टेंस
हाई हो गया ना, तो हाई होगा ना, क्योंकि वो भी फ्री। भाई करंट किसकी वजह से होता है? चार्ज फ्लो से। तुम्हारा चार्ज किस फॉर्म में? आयन फॉर्म में। वो मूव ही नहीं हो रहा है, तो रेजिस्टेंस ज्यादा हो गया इसका मतलब। अगर चार्ज मूव नहीं हो रहा है तो करंट नहीं हो रहा। अगर करंट कम है मतलब रेजिस्टेंस उल्टा है, थोड़ा समझने। मतलब फ्री आयन अवेलेबिलिटी कम हो जाएगी, कॉन्सेंट्रेटेड इलेक्ट्रोलाइट। Shall we proceed?
Yes, sir.
Now is combination of resistors. So there are two types in which resistances can combine: series and parallel, right? So first let us understand series combination. So when do we say resistances are combined in series? When they are connected like this, one after the other. Okay. So there are three resistors, 1, 2, and 3. So you saw those resistors, right? Color-coded resistors. It has two terminals. So when one terminal is joined to the next resistance and repeated, so they are said to be connected in series with each other. Now we will connect a source of cell, right? And a key. Let us say this is our series connection, a simple circuit. Now, when there is no internal resistance, what was the formula? E is equal to V plus IR. So when small r is 0, then E is equal to V. Got it? So here, is there any internal resistance shown?
No, sir.
That is possible only for ideal case. So this is the ideal cell. So what I'm showing? V. Because E is equal to V then, right? So that is possible. Now there is a current, let's say I. So what is the path? Only one path. So in series connection, same current flows through all the resistors. So in series connection, same current flows through all resistors. Okay, what about potential difference? So if you apply Ohm's law, what is the current flowing through R1? I. So potential drop will be IR1. Okay, so every resistance will have a potential drop. What is V1? IR1. What is V2? IR2. What is V3? IR3. This is plain application of Ohm's law. So therefore, in series connection, this V is divided into IR1, IR2, IR3, right? Okay. So therefore, V is equal to V1 plus V2 plus V3, right? So if I replace these three resistance with the equivalent resistance, just one single resistance, which is the equivalent resistance of R1, R2, R3, then I'll get this circuit. Yeah. So I have V, I have K, and let us say RS is such that same current I is flowing through it. Then what is V? Then V will be equal to IRS, right? So by Ohm's law, what will be V then? IRS?
Yes, sir.
So therefore V is equal to IRS. IR1, IR2, IR. Okay, so I gets cancelled. So we get the equivalent resistance in series combination is just the sum of resistances. And this is true for any number of resistance. Let's say there were n resistance. You just have to add them to arrive at an equivalent resistance of series combination. Okay. Now let us see what is parallel. So, parallel complement. So again, let us say we have three resistors, R1, R2, R3. Again, the cell is connected. Now, it is showing, let us say I current is drawn from the cell, right? What about this point?
It diverges.
It gets divided.
Yes, sir.
Let's call this current I1,
I1, I2.
I2 and I3. What about potential difference?
It remains the same.
Same potential across R1, same across R2, same across R3.
R3.
So in series, current was same, right? Same current, but in parallel, what is same? Potential difference. Okay. So therefore, now what can be said about current? Current is divided. So I is equal to
I1 plus.
I1 plus I2 plus I3. Right? So if we had an equivalent parallel resistance, let us call it RP. And the same cell is connected so that the same current is drawn, right?
Yes, sir.
So what will be I then? V by RP.
Yeah.
Simple application of Ohm's law. What will be I1?
V by R1.
V by R1.
V by R2.
Okay? So what do we get? All the V will be cancelled. So we get 1 upon R parallel equal to 1 by R1 plus 1 by R2 plus
1 by R3.
and it is true for any number of resistance.
Yes, sir.
Okay. So what is R parallel? R parallel is reciprocal of this. 1 divided by 1 by R1. 1 by R2. Okay. So whatever answer comes, you have to take the reciprocal of that to arrive at the final answer.
Yes, sir.
Okay. So maximum mistake happens here. You calculate this and you say that this is the answer. With some practice, get it right. So any questions?
No, sir.
Okay. So we have seen the series combination and the parallel combination separately. There could be a situation where you have both combinations together. So let us say we have so tell me what is the total resistance between AB? All resistances are 1 ohm. Calculate.
Yeah. Two. 1, 2.
All are 2 ohm. Find out what is the equivalent resistance. Find the resistance between A and B. What is it? 2 ohm.
2.
How?
So 1 and 1 are in parallel, so 1 O and 1 plus 1 2.
1 and 1 are in parallel, so 1 over.
Yes, ma'am.
Okay, do that.
Journey 1 by 1 plus 1 by 1. 1.5. 1 by 1 plus 1 by 1.
Find out. 2 ohm is not correct. दोनों कितना है?
1.5.
इसका कितना हुआ? 0.5 plus 1. क्योंकि इसका जो आंसर आएगा वो इसके साथ सीरीज है. This will be 1.5. Right? Everybody got it? ये कैसे 1.5 है? देखो 1 by RP is equal to 1 plus 1. This is 2, right? So what is RP? Therefore, RP is equal to 1 by 2, which is 0.5. So 0.5 इसका आ जाएगा plus 1, that is 1.5. समझ आया? देखो यही गलत होता है जो तुमने किया ना. तो अभी इसका करो. पेपर पे करो फटाक से, ऐसे सिर में मत करो, वो फिर wrong habit build हो जाएगी. Do it on the paper. How do you simplify? Now this 2 and 2 are they in series?
Yes, sir.
2 and 2 ऊपर वाले they are, so ये 4 हो गया. 4 in parallel with 2. So parallel में हमेशा देखो एक चीज याद रखना, तुम्हारा आंसर करेक्ट है कि नहीं. पैरेलल में जितने भी रेजिस्टेंस है उसका आंसर जो स्मॉलेस्ट रेजिस्टेंस है उससे भी कम आना चाहिए. ठीक है, यानी पैरेलल ऑफ 1 and 1 हैज टू बी लेस देन 1. व्हाट इट? तो अभी यहाँ पे कितना है 4 और 2, तो उसका आंसर 2 से कम आना चाहिए. और फिर वो ये जो दो सीरीज में है 4 प्लस ये आंसर फटाफट बताओ कितना होगा. और एक और शॉर्टकट है, अगर दो ही रेजिस्टेंस है, समझो देयर आर ओनली 2 रेजिस्टेंस R1 एंड R2. ठीक है, तो इसका पैरेलल कितना आएगा? RP is equal to product by sum. करके देख लो वही आएगा. 1 by RP is equal to 1 by R1 plus 1 by R2. क्या होगा? R1 plus R2 by R1 R2. उसका रेसिप्रोकल R1 R2 डिवाइड बाय. ठीक है, समझ आया? तो जहां पे दो रेजिस्टेंस है उसमें ये शॉर्टकट यूज कर सकते हो, प्रोडक्ट बाय सम. तो कितना आया?
16 by 3.
ये प्रोडक्ट बाय सम कितना आ गया? तो 4 to the 8 डिवाइड बाय 6. 2 प्लस ये तो कितना हो गया? ये 2 4 8 ये आ गया. सो दिस इज 4 प्लस 2 4 8. This is 12 plus 4, 16 by 3. 3 4 is 15. 5.33. Got it? So we just did parallel and series combination. साथ में कुछ किया. How much more time?
8 minutes. 3 minutes.
ठीक है. अभी हम next class में we'll do all numericals.
Okay, sir.
There is unit C, which is about electric energy and power. Now we have sit down everybody. Sit down. 5 मिनट है, पहले से बैग पैक करो. I am discussing. Now look at this circuit. Very important. The last part. Don't wind up yet. After 5 minutes. So we have this circuit. ठीक है. Right. Let us say. So what is happening is this cell, right? Let us say charge Q flows for time T. Right? If charge Q flows for time T, then the current going through the circuit is Q by T. Right? So let us say work done in moving this charge Q is W. So if W is work done in moving charge Q, W is work done in moving charge Q through the circuit. Right? Then who is doing the work? Potential difference. Right? Then B is equal to by definition. Correct? Isn't it? If W is the work done in moving the charge Q through the full circuit, and by definition we know that V must be equal to W by Q. Right? So what is the electrical energy spent? It must be equal to the work done. Right? Therefore, W is equal to QV. Right? So this is the where W is now electrical energy. Energy spent. Understood? So W is the electrical energy spent. But what is Q then? Q is
Which is a charge that is
IT. So therefore, write down these are very important simple derivation I'm giving you, right? So W is equal to Q is IT into V. Since I is equal to Q by T, this means Q is equal to IT. Okay, so this is the expression for electrical energy in moving a charge Q through the circuit. Now, what is power? Which is or energy spent per unit time. What is power? Electrical power. Therefore, power is energy upon time or work upon time, right?
Yes, sir.
Work and energy are same. What is energy? ITV. Therefore, P is equal to ITV upon T. Right? Everybody just get fumbled in these expressions to derive it. Okay. So this is equal to IV. So there's a very simple derivation in 2 steps. If you first you should know how to derive this expression. Okay. The power has 3 forms, just like Ohm's law. So by Ohm's law, I is equal to V by R, right? So this is V square by R.
Yes.
Also, if you eliminate V, you can write I is equal to V is equal to IR.
I swear.
Power के 3 formula
Power.
और V square by
Yes.
कितना आसान है, बहुत पावर है, बहुत. So basically, it's very simple. You have not done anything new. You just rearrange things. You just rearrange things. Okay. 2 minutes है. किसने किसने लिखा, चलो नोटबुक चेक कर लो. Let me read. So it will be available on video. Okay? So देखा है ना? बहुत अच्छे. Everybody clap for it. सबको समझ आ गया ना? Next class, numericals. Don't get after the mix.
सब तेरे ऐसा नहीं होता है जैसे अपना 20 का बच्चा होता है अपने प्रिंसिपल को होता है यो सब तेरे ऐसे नहीं होता है सबके पास कैसे देने से कभी कोई नहीं होता
यार मैं कंफर्मेशन के लिए सर को बोल रहा हूँ, सर ताली बजाने बोलते सबको. ताली वाली लिख दे रहे
गार्लिक का टेस्ट आता है मैं शौक हो गया क्या कंप्लेन ऑपरेट डाला क्या किसी ने मैं तो बोली सीधे तो सिग्नेचर आया मैं डर गया भाई ये डाल दिया क्या क्या मेरी को मजे ले लो टॉपिक और दिखाए कैसे मेरे बोले तो